Hello and welcome back to our course. So in the last session we introduced a smarter solution to our optimization problem, and we set random start to 800, and then we calculated the amount of unique stickers at our random start of 800, so 444.7, and then we calculated the difference between our result and our target. So our target is here 550. And then we adjusted the random start by a multiple of the difference to speed up our algorithm. So if our result is far away from our target, we increase our purchase stickers by a higher amount. And if we are very close to our target, we change our purchase stickers by a smaller amount. And therefore we introduced the so-called learning rate as a multiple of this function here. And we figured out that the value of 7 is an appropriate value for the learning rate to actually speed up our algorithm. And then further we limited the number of optimization iterations to 20 and called it epochs. So we have only 20 iterations, and after 20 iterations our algorithm automatically stops. So now if we start with 800, we are getting very close to our target of 550 after only 4 iterations. But we have 20 iterations, and in the next 16 iterations, doesn't make it any better actually, and this is quite inefficient. And the idea is now to stop our algorithm if we are very close to our target. So say if we have only a tolerance of 0.5 stickers, then our algorithm should stop, and therefore we introduce the parameter tolerance, set it here to 0.5. Let's run the cell here. And then we are copying here our for loop from above. So, what we are doing, we are introducing here an if statement. So we are calculating our result based on random start, calculating the delta, and then printing the delta and random start, and then we are checking if the absolute difference is smaller than our tolerance. So if our difference target minus our actual result is smaller than, let's say, 0.5, and if it's smaller, we break. So we just stop the iteration and have our result. And if the difference is larger or higher than our tolerance, then we adjust our random start one more time and do one more iteration. So let's run the cell here. And there you can see, so after our 4th iteration, our algorithm stops here. So before we had here, after our 4th iteration, we had also a result of 549.9 at 1480 stickers. And our algorithm repeated 16 times more until we reach 20 iterations, and here it automatically stops as our tolerance or our difference of 0.1 is smaller than our tolerance of 0.5. And then in the end we can print out our random start, and now we are having our results. So we should buy 1480 stickers to have an expected unique stickers of 550. And now we can also write a solver function and pass all arguments that we also pass to our sticker album function. So album capacity, random start, simulations, seed, and also our optimization parameters like target, learning rate, epochs, and tolerance. And this function should give us, so for example, let's assume we have now an album with a capacity of 350, and our target is 300 and our tolerance is 0.5. So this function should just return us how many stickers we should buy to have an expected unique stickers of 300. And therefore we copy here our code from here above, paste it here. And what we actually change here, we pass here inside our function optimize our function sticker album, and instead of having concrete numbers here for the arguments of sticker album, as we had here, 610, we pass the values that we passed in our function optimize, so in our outer functions to say. So now we have here album capacity is album capacity as we defined in our optimize function. Purchase stickers is the integer of the random start, which we defined here in our optimize function, and so on. And yeah, the rest of the code is actually the same as we already know. And yeah, in the end, the optimize function should us return our final random start, or our final result, how many stickers we should buy, and actually the result itself. So how many unique stickers can we expect with the final random start. All right, so let's define the function here. And now let's say we have our album with the capacity 600, and we have a random start of 800 and a target of 550, and we want to optimize and then figure out the amount of stickers we need with 1000 simulation and a very small tolerance of 0.1. So we should expect a result of about 1481. So we had that before. And still we are having here, we are printing for each iteration, we are printing out the results. So if we have 800 purchase stickers, our expected unique stickers is 442. So now you can see here our algorithm stopped. So we have a result of 550.098. So the difference to our target is smaller than the tolerance. And yeah, we end up with the amount of stickers we should purchase of 1492. So we are seeing here the intermediate steps and also here the final result. So we returned our final amount of purchase stickers and our result here. And we can also cross out here the option that we print out the intermediate steps, so we can do that. And then let's assume we have a completely different album of a capacity of 471, and our target is 421. And we set the random start to 200. We want to have 100 simulations, and we can accept the tolerance of 0.2. Then we can optimize our album, just with here the optimize function. We should have run our optimize function again. So here we crossed out the print of the intermediate results, but of course we have to also run it. And then let's run it again. So this is our result. So in order to get an expected unique stickers of 421, so exactly it's 420.86, we need to buy 1060 stickers. So this is our optimize function, and it seems like it works pretty well. So now we have a quite smart algorithm here. In the next session we will also visualize our results. So a graph sometimes tells us more than 1000 numbers to say. So hope to see you there. Bye.